Okay, I'm going to try to get through this before my dog goes bananas and demands my attention. Um, but I have kind of smushed together um, some stuff from three different scripts from last year. It was the stuff from week 9, which I kind of am a little behind on, and then week 10, and then I pulled actually something out of week 11 because I think it'll be useful for you sooner. I just happened to stumble onto this function later on in the semester last year. Yeah, so I'm going to go ahead and run the first couple lines of code and import my current data set that I have out there. And like I was saying in class the other day, to run a multiple regression, it's not really all that different from running the bivariate regression. We're going to have the dependent, it's the LM function, and then the dependent variable, and then a tilde, and then our independent variables. So rather than just having the one like we did with just a simple bivariate regression, we're going to have several, and they're going to be separated by the plus sign, which is also, again, similar to how we did two-way ANOVAs. And then comma data equals my data. So remember that we're not putting my data $, and then the variable name when we write out the formula for a regression. We just include the variable name and then enter this last argument here that specifies what data set we're talking about. So if I run this to generate our first model, and then pull up a summary, you see it gives us all of this information here with, remember in class last week I said that I usually name my variables something more descriptive. So this is actually party ID. This is ideology. And you can see that we've got a few significant variables here. Basically everything but female. Education is close, 0.057. So if we had a hypothesis where we were predicting direction, technically that would be one tail, and that would be significant, but two tail it would not. There's also a bunch of other stuff that is included in the model. You see a lot of it here, but if you open this up over here in your environment, it kind of similar to the $, in a data set where you have your data set and then a $, and then your variables. In a list, you're gonna which is what the model object is, you're gonna have the name of the model object, and then the $, and then while these aren't variables, they're just different things that are contained within this list. And towards the end, I'm going to show you a way to extract some of this information, because later on in some of the things that we do, it will be useful to know that. So yes, the scale function that I had talked about in class also. Like I said, Katie McCabe gave me this function. I did not just come up with it on my own. But the math goes something like this. Subtract the minimum of x, disregarding NAs, from x, and divide that result by the maximum of x, disregarding NAs, minus the minimum of x, disregarding NAs, in other words, the range, and then subtract 0.5 from all of that. So if you were to leave off this subtract 0.05, this would give you actually a scaled version of their variable that ranges from 0 to 1. And to get it so that it runs from 0.5 to negative 0.5 to positive 0.5, you want to just add this last argument to it. But you can just clearly copy and paste this into your own scripts. But that adds the function there into our environment. You see it's over here now, so you can use it. And then you just use it like any other function. So I'm going to create scaled versions of these 4 variables: party ID, ideology, education, and income, just by using the function, calling the function, and then telling it which variable to apply it to. Okay, so then this st function is just a very handy function that'll generate a nice neat table of descriptives, which is something that you are asked to do on homework. This is found in the vtable package. So if you have never installed that package before, you'll want to run this line of code first without the hashtag. And then after you install the package, then you'll want to run this line of code to open the library. And then the function itself, the input for it needs to be a collection of variables. So you can either subset and then create a new data frame for the input, which would look something like this. So I'm creating this new data frame of just these variables, calling my data. I want all rows, but just these columns. So you see that shows up over here, 1,200 observations of 6 variables now. And so then you feed that into the st function, the new data set. And then you also need to add this argument out equals return, because the default argument, which you would get if you only had, say this, is HTML. But if you add this argument and you say return, it will return a nice little table down here in your console of descriptives. So you have the variable name, the non-missing n, the mean, the standard deviation, the min, the max, and then the first quartile and the third quartile. You can also skip the subsetting step by just doing something like this, where you just kind of like basically take this part of your subset and feed it in here instead of creating an object first and then feeding it in there, and come up with the same thing, this table here. Predictions. Okay, so this isn't quite as fancy as I claimed the other day, I guess. There is still a little bit of, I don't know if you call it manual, but just like, you don't snap your fingers and it just spits out all of your predictions for you. But, so instead of running the model like we did last week, where we just had LM and then your dv tilde, your independent variable, we're back to bivariate regression here because this is from homework 5. And then the data set, just by itself, we add this last little argument, na.action equals na.exclude. It's telling it to exclude missing values. And it kind of does that. It's ours just kind of finicky and weird. It does that automatically in your summary. It tells you like, X number of observations omitted due to missingness. But for some of these, for this prediction function, you get an error if you don't add this argument to be explicit that you want what you want it to do with the NAs. So we'll run this new model of this bivariate regression, and we've got, you see the intercept of 78.665. Remember that's because we have party ID centered on 0. That is for independent independence, which I have here. And then of course, since the coefficient for for Republican or party ID is negative 3.26401. You just doing the math, you wind up with all of these values here for the different categories ranging from strong Dem to strong Republican. So instead, the predict function can generate predictions for each observation in the data set. And what you actually end up doing is creating a new variable of the predicted values for our Y, which is the scientist's feeling thermometer in my example here. So we're going to create this new variable of scientist predicted, and then use this function predict. And then you put the model number in there. Why is that not working? It did when I was... Why are you not working? It did the first time I ran this. Oh, model 2. That's what I get for changing shit as I go. Okay, so this should work this time. There we go. Okay, so if we look at the different variables in the data set now, you notice that now we've got one new variable, which is this variable scientist predicted with all the predicted values in the data set. So then, and this is what I mean about it's not 100% like snap your fingers and it's done. You have to still write the formula to calculate the mean for every single value, which if you run that down here, and if you were to take these values and compare them to these, calculating them by hand, you see they're pretty much the same. So let's see, strong Dems 88.458. If you round, yeah, that's what that is. 85.194. 81.929. Dependently them. Yeah. And then on the other side, 75,402. So this one would be one where it'd be off just a smidge. So rounding errors, 72.137. Ooh, that one's off even a little bit more. And progressively, it would probably continue to, I bet this one's off even more. But all of that is just related to rounding error. But for the most part, I would say that's maybe still a little bit easier than calculating it by hand. So the other things that I was talking about that we can extract from this regression model, you can pull out just the coefficients. So you get like a little vector, basically. If you were to turn this into an object, I think it would be a... Yeah. Let's see. Yeah, it's a vector. We can also get the confidence intervals, which then we could turn this into a data frame, or a table of coefficient results only. You know, like I said in the, let's see, in a regular model summary, you get all this extra stuff, like all of this and all of this. If you run and ask for just this, it's an easy way of shoving all of your coefficients into a data frame. Also your standard errors, your t-values, and your p-values. And then so just like you can get this, then you can extract like just specific columns of this. So this one is just the standard errors, which becomes a vector. Similarly, you could do just the t-values, just the p-values, and then of course we already did the coefficients has its own. We can also get the variance covariance matrix out of a model. We can calculate standard errors from the variance covariance matrix. And finally, we can get the degrees of freedom. So all this stuff, like, is various stuff that Rick has pointed out in lectures, or that he will be pointing out in lectures. And it's a handy way to extract data and manipulate it if you need to for any reason, like maybe completing some of the upcoming homework assignments. Finally, we can also plot our results using ggplot. This is just a plot of the regression line. Which model? I think this doesn't work with the model. You actually just enter your data frame and then you tell it what your X and your Y are. And then it'll plot the regression line. That's what this method equals LM is for. Standard error equals false. Color equals red gives you, so this says to leave out the standard error. So I assume, so we don't get, I think this might have to do with not getting confidence intervals, but I don't really remember. This line puts the title. This line labels the axes. And this changes the theme, or basically just the background coloring. And I believe that is all I've got for now. This probably seemed a little disjointed, like I'm hopping around to a bunch of different things, and that's because I am. It's not really, it's a lot of tricks and tips, essentially, to make your life easier going forward in some of the upcoming homework. But it doesn't really all fit together very well. So it's not like it's like anything that's building off of each other. But you will find it all useful in the upcoming weeks.